Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6 from the February-March 2022 Cambridge 9709 paper 5 variant 2, the statistics S1 paper. Here it tells us about a factory that produces chocolates in 3 flavors: lemon, orange and strawberry, in the ratio 3 to 5 to 7 respectively. So lemon 3 parts, orange 5 parts, strawberry 7 parts. Nell checks the chocolates on the production line by choosing chocolates randomly one at a time. Find the probability that the first chocolate with lemon flavor that Nell chooses is the 7th chocolate that she checks. Okay, so now we're going to say let the random variable L be the number of chocolates chosen until a lemon is chosen. Until a lemon is chosen. Okay, so the random variable L is the number of chocolates chosen until a lemon is chosen. So the random variable here is going to be such that it is a geometric distribution. It's a random variable which is geometrically distributed. So the L is such that it's geometrically distributed, and the probability of success is going to be, well, it's either lemon or not lemon. So here we're concerned with the probability of choosing a lemon. Would be, we're going to have 3 out of 15. Right? Because that's 8 plus 5, 15. 3 out of 15. 3 out of 15 is 1 over 5. And the probability of not lemon is going to be 4 out of 5. So we can say in our case, the probability of success is 1/5. And the probability of success is, we're going to denote it as P. So P is 1/5 and Q, failure, is 4/5. We consider a success as choosing a lemon here. So it's a geometric distribution with the probability of success 1/5, and we can say from this that the probability that L is equal to 7, okay, that means the 7th that she chooses is going to be, the lemon is going to be such that the first 6 are going to not be lemon. So you have 4/5 times 4/5 times 4/5 times 4/5, which is 4/5 to the power of 6, times the 7th is going to be 11 times 1/5. And this will give you your answer. Okay, so this is this geometric distribution here. Now we're going to get the calculator and work out this. So we're going to have 4/5 to the power of 6 times 1/5. Okay, and that gives us 0.0542. 0.054248. Second, 0.05. Oops, let me just write this again. I've written a completely different number down. Okay. What I'll do is this to make it easier. Okay, so 0. This is where I can see what I've got there. So 0.05242. Okay, remember in the end you should write to 3SF, so I'll just put 0.0524. Okay, so that's fine as your answer to 3SF. Okay, so there's the answer there, and that's the answer to part A. Okay, so it's a geometric distribution, so that's how that works. Then it says find the probability that the first chocolate with lemon flavor that Nell chooses is after she has checked at least 6 chocolates. So after she has checked at least 6 chocolates. So basically, we want to find the probability that the random variable L is equal to 7 plus 8 plus 9 plus, and going on until forever. That's what we want to find. How do we work that out? Well, there's a formula that we should know from our understanding of geometric progressions or geometric distributions, which it's not in the formula sheet, but we should learn it when we're doing the course. And basically, that formula is as follows. Okay, so we can see here the formula of that we've got over here in this place. This formula over here, that the probability that x is greater than r is equal to q to the power of r. Q means the probability of failure. Okay, so this is what we're looking for. So the probability that L equals 7 plus L plus 8 plus 9 and so on is the same as saying the probability that L is greater than 6, because remember it's a discrete random variable. So after 6 comes 7. So this would include 7, 8, 9. Okay, so greater than at least 6 chocolates means, okay, what we're looking for is, she's already checked at least 6 chocolates, so that you want more than 6. So that's going to equal Q, which is 4/5, which is the probability of failure, to the power of 6. And that will give you the probability that the random variable is greater than that value R. So this is going to give you your answer. So it's going to be 4/5 to the power of, 4/5 to the power of 6, which gives you 0.262144. 0.262144, which to 3SF would be 0.262. So there's your answer to part B. Okay, so that's all about geometric distribution here. Okay, now for part C, it says surprise boxes of chocolates. Each contain 15 chocolates, 3 are lemon, 5 are orange, and 7 are strawberry. Petra has a box of surprise chocolates. She chooses 3 chocolates at random from the box. She eats each chocolate before choosing the next. Find the probability that none of Petra's 3 chocolates have orange flavor. So you have 3 lemon, 5 orange, and 7 strawberry. She takes 3 picks. Okay, so none of them can be orange flavor. So you're going to find the probability that none of them are orange flavor. So that means the first one she picks, there's 10 that are not orange out of 15. Okay, there's 15 altogether. Okay, there's 15 altogether. 10 of them are not orange out of 15. Then she's going to take another pick. Okay, for the second pick, there's 9 chocolates that are left that are not orange out of 14. And then she's going to take a third pick. In the third pick, there are 8 chocolates left which are not orange out of 13. Okay, and that should give you your answer. That's not orange, and then not orange, and then not orange again. Okay, and because she's taking them and eating them, all right, there's going to be 1 less each time of each, and 1 less each time overall. Okay, so 1 less orange, okay, 1 less not orange every time she picks, because you want to find all 3 of them are basically not orange. Okay, none of them have orange flavor. So this will give you your answer. Okay, so we can calculate this. 10 over 15. You have 10 over 15 times 9 over 14 times 8 over 13. That gives you 24 over 91. 24 over 91. You can leave your answer like that, that's fine. You can leave it, that's an exact answer, that's better. Okay, so there's the answer to part C of this question. Okay, now for part D, it says find the probability that each of Petra's 3 chocolates has a different flavor. Okay, So we have 3 lemons and we have 5 oranges and 7 strawberries. And we want to find that when she takes 3 picks, and when she's taking the pick, she eats what she picks. So there's no replacement. That all 3 of the different flavors all the 3 of the flavors are different. She never chooses the same flavor twice. Okay, so there's a number of ways we can do this. We can think about the probability tree for this. Okay, which is a bit maybe complicated because there's lots of different options. Okay, or we can consider, the number of ways you can do this in other manners. If we think about the tree first, just to give you an idea of what's happening. So it's like she's going to choose a lemon and then an orange. So just a lemon and then an orange and then a strawberry. That's one way of doing it. Okay, how many different ways of doing this would there be? Okay, how many different ways would there be of arranging these? Okay, there would be basically 3 factorial ways. So if you multiply this by 3 factorial. So the probability of a lemon, okay, would be 3 out of, there's 15 altogether, times for a orange, there'll be 5 out of, now there's 14 left, times a strawberry, there'll be 7 out of 13. Now, the numerators will always, be the same altogether. So, for example, if I chose, orange and then lemon and strawberry, for example, orange would be 5 out of 15, then lemon would be, 3 out of 15, and strawberry would be 3 out of 14, and strawberry would be 7 out of 13. So the denominators in the end will be the same numbers, and the numerators will be the same numbers multiplied by each other, but these can be arranged in different ways, in 6 different ways, 3 factorial ways, okay, of arranging these numbers, okay, these different letters. So we're going to multiply this by 6, and that should give us our answer. Okay, so let's see what that gives us. So we have we have 7 here, and we have 5 here, and we have 3 here. And we're going to multiply this all by 3 factorial, which is 6, 3 times 2. And that gives us 3 over 13. All right, so that's how we can deal with D. I mean, if you think about with the tree, you could do it as well, but that's going to take a long time. But just imagine you have L, O, S, and then you have L, O, and S. And you're going to have L, O, and S, and again, L, O, and S, and the third time as well. It's going to be a bit difficult to draw it, but you're going to have you're going to have 2 from here, which would be, you'll have LOS and you have LSO. So from here you'll have 2. And from this branch in the end, you'll have OLS and OSL. Okay, so there'll be 2 branches from these altogether. And from here you have SLO and you'll have SOL. There'll be 2 from here as well. You can't have anything repeated. So there's going to be 6 different ways, okay, which is what this times 6 is. And all the probabilities will end up being something like this. Okay, it will always be that these will always be the same because you're choosing, there will be 3 lemons and there will be 5 oranges, there will be 7 strawberries. You haven't chosen one of them before, so there'll always be 3, 5, and 7, or 7, 5, and 3, or 5, 3, and 7. But the denominators will always get 1 less because you've got 1 less to choose from each time because you're taking one and eating them. So all of those 6 different ways will have these same things. So that's the logic behind writing this. You can think these 3 have to be basically written in 6 total different ways, such that there's, no repetitions. So that's basically the logic behind that part D. It's pretty simple. And now for part E. Okay, part E. Okay, now for part E. It says, find the probability that at least 2 of Petra's 3 chocolates have strawberry flavor, given that none of them have orange flavor. Okay, so we have that famous phrase again, given that. Okay, so this is conditional probability. So conditional probability, for example, the probability of A given B is equal to the probability of A intersection B over the probability of B. So this is given. So that has to be our denominator. So in this case, the probability of orange, not orange, not orange. Okay, we already have that our denominator, I think from part, none of them are orange. Yeah, part C, which is 24 over 91. So we already have this 24 over 91. That's our denominator. Okay, that's our denominator. Okay, so this is going to be the probability of not orange. And on the top, we're going to have basically none of them are strawberry intersection with non-orange, which is basically if none of them are strawberry, okay, sorry, at least two strawberries, given that none of them are orange. Okay, so we're going to find the probability of at least two of them are strawberries, given that none of them are orange. So at least two strawberries, but there's a condition, okay, given that, or intersection with no orange. This is what the numerator has to be. Okay, the numerator has to be the probability of at least two strawberries, okay, intersection with no orange. So basically there's an option where they're all strawberries. They're all strawberries. In which case, remember there's how many strawberries? We have strawberries 7, we have, what was it? It was lemon, orange and strawberry. So we had lemon, there was 3 lemons. And we had 3 oranges, 3 lemons, we had 7 strawberries, and we had 5 oranges. Now we've got to consider the case here where we're not considering any of the oranges. Okay, so we got to find the case where we have basically at least, so we have all 3 strawberries plus the probability that we have 2 strawberries and 1 lemon. 2 strawberries and 1 lemon. No orange. We're not considering the oranges now. Okay, because we've got to, our sample space doesn't include oranges anymore. Only the strawberries and lemons. So you can have either SSL, okay, or you can have SLS, or you can have L. So you're basically going to have this. You're going to have SLS, or you can have LSS. Okay, so you can have strawberry, strawberry, lemon, or strawberry, lemon, strawberry, or lemon, strawberry, strawberry. Okay, so those are the 3 different cases. It's going to be basically one of them multiplied by 3. So I'll just write it like that in the end. So the probability of 3 strawberries, well, you have 7 out of 15 for the first. And for the second pick, there's only 6 strawberries left out of 14. And for the third pick, there's only 5 strawberries left out of 13. And then you're going to have plus 3 times one of these. It'll all be the same, just different places. So it'll be 3 of, now strawberry, strawberry, and then lemon. So you have strawberry, which is, again, 7 out of 15, times 6 out of 14, times lemon, that's going to be 3 out of 13. Okay, we're not considering the oranges because they're out of the sample space now. But these are the probabilities of each of those, and we've got to combine those together now. We've got to add those together. So that's the outcome where there's 3 strawberries. That's the outcome where there's 2 strawberries and 1 not strawberry. But because we're not considering oranges, it's 2 strawberries and a lemon. Okay, so now we're gonna find out the probability of that. We're going to put that in the calculator and work it out. So you have 7 over 15 times 6 over 14 times 5 over 13. Okay, then we're going to add to that 3 times 7 over 15 times 6 over 14 times 3 over 13. And that gives us 14 over 65. 14 over 65. So the answer that we're looking for, the probability that we have at least 2 strawberries given that there's no oranges is going to equal 14 over 65 divided by 24 over 91. Okay, this conditional probability, which gives us, so we'll take this answer and we'll divide it by 24 over 91, and that gives us 49 over 60. 49 out of 60, and there's the answer to part E of this question. And that concludes this question from the Statistics S1 paper from Cambridge. Other questions from this paper can be found in the playlist that will appear on the top right of the screen at the end of the video. Other questions from the topic of, this is, I guess, to do with geometric distributions as well as probability, can be found in the playlist Geometric Distributions here and Probability over here. You can subscribe to the channel by clicking on this link. Thank you for watching and see you soon.